Hello, testing, testing. Hello, can you hear me? Hello, if everybody can hear me, please type something in the chat. Okay, great. So I see now 9 users watching, and it's the time. So let's start. Everybody, good morning and welcome to this live training on our JEOL 3100 microscope. Today I'm gonna show you and walk you through the standard procedures for stem alignment and image acquisition. So first, I'd like the first-time trainees, please type your name and email address in the chat area so that we can update your training record. So after this training, you'll be given the daytime access, so you can book the time by yourself. But only for the first time trainees, I do require a second time in-person one-on-one training. So after this training, you will be able to reserve the time by yourself, and after you get the reservation, please also send me an email. The second time training will take like 30 to 60 minutes. So of course, all other users are welcome to watch. And this training is made for very beginner levels. So I'll only just show you how to do the alignment and get a good stem image. So also for the first-time trainees, if you are here, you made it here, I think you should already go through that TEM seminar. We made it online, so you should be able to tell the capabilities of our TEMs and the difference between them. So first, a very brief overview. This TEM JEOL 3100 is our high-end TEM. It has two aberration correctors, one for the stem STEM mode, the other one is for the TEM mode. So here, this TEM can give you, both in TEM mode and stem mode, it can give you about 0.6 angstrom resolution. So it's really a high-end TEM, and besides, it can also do fast EOS mapping with our direct electron camera K2, which is newly installed. But I would say the aberration correct TEM and the EOS are more like for the advanced users. So if you you are interested in learning those two techniques, please schedule with me for another training. And today's training will only focus on the STEM imaging. Okay, so I think right now on your screen you should be able to see our whole TEM. I will first point out. Hi, by the way, I'm Tao. So I will first point out some important parts on our TEM. First, see this. This is where your sample goes in, and usually you use this standard JEOL sample holder. We have a viewing screen with a phosphor screen inside. So this is just for checking the beam. And see, we have 3 computers or 3 monitors. The middle one, this one is for we call it TEM PC. So this guy is for like all those kind of operations on the TEM, like alignment, changing something. So for those kind of operations, you have to go to this PC, and again we call it TEM PC. This monitor, we call it Gatan PC, and we use it for image acquisition. The software because the software we're using is the Gatan digital micrograph. So we call it Gatan PC. So all the imaging and the spectrum acquisition is done on that PC. And the last one, this guy is called Cosmo PC, and it's basically the control PC for our aberration correctors. Because the software running on this PC is called JEOL Cosmo, COSMO. We call it Cosmo PC. So for you only need this when you do alignment, when you really want to adjust the correctors and push your resolution. And also another important thing is this. See, it's basically a liquid nitrogen dewar, a tank. And if you are the first time user of the day, you will see, let me see, this thing inside that dewar, and you have to take this thing out and fill the liquid nitrogen inside that dewar. See this funnel here? I put this funnel here and use that funnel to fill the liquid nitrogen. And I think everybody knows where our liquid nitrogen is. And today I already filled it, so I won't bother showing that again. It's quite straightforward. Okay, and let me switch over to one of the PCs. So right now on your screen, there should be the Cosmo PC. So this software is the Cosmo, but before doing anything, just like all other instruments, you have to check a few things to make sure that the instrument is ready to use. So on this PC, oopsies. So except the Cosmo software, we also have this so-called AMCAP. Some setting is weird. Probably you see the black screen. So this AMCAP is just a live camera viewing the pressure gauge. Oh, maybe I can, Wait a minute, maybe I can do this. Go. Okay. Now I am showing the same monitor, the Cosmo PC, and you can see if you move your mouse over two windows. This is the AMC cap, and if you open it, this is a live image of our vacuum gauge, and this, you see this black marker. So make sure the vacuum is below this black marker. If it's not, then something's wrong. Like if you see this needle is somewhere here, definitely something's wrong. Please tell me. And also, if you see this needle is like pointing to the 0, that means this gauge is not on. Also, something is wrong, so please tell me. All right, let me switch over this guy. Okay, so now I will switch to the TEM PC. You should be able to see the desktop, the desktop of the DTM PC. So you should be able to see a few different windows. Those are just the controlling software for the TEM, and you have to make sure a few things. First, let's see this here. ACC means accelerating voltage. It's make sure it's set to 300 kV. So this TEM has 300 and 200 and 80 kV. So 3 settings, but usually we do everything in the 300 kV. So make sure it's set at 300 kV. And here, make sure it's in the scanning mode if you want to do STEM imaging. And the spot here, make sure it's 7C. It's kind of standard configuration. And the camera lens here, make sure it's 15 centimeters. That's standard for getting STEM high-def imaging. And here, make sure, so you see X, Y, Z, D, and also TX, TY. That means tilt X, tilt Y. These are the holder positions, the sample positions. So to start, make sure these are all 0. So or we say they are neutral. So it's okay to take the holder out. And see this window, it's called ASID control panel. You see this ASID mode. So you see this TEM, then ASID. So if you select ASID, it's in the STEM mode. Here we'll say scanning. Because most of the time we use it in the STEM mode, so make sure it's in the ASID mode. All right. So that's a brief overview of the TEM and checking things. So let me switch over to here. Okay, now we are ready to take the holder out. So I'll repeat. So make sure the vacuum is okay on that screen, and the sample holder position, they are all neutral. So then let's take the sample out. Let me see if I can move this camera a little bit closer. Okay, it looks like that's the closest I can get. I think we have separate videos for holder insertion retraction on the JEOL TEMs. They already posted on our website. So if you, but I will do it anyway. If you can't see some details clearly, you please go ahead and find those 2 videos with high quality. So basically, see, this is the holder, and to take it out, just, oh, I forgot one thing. So make sure you get a pair of clean gloves. You get a pair of clean gloves on your hands so that you can protect our equipment, and you also can protect yourself. So now I got the clean gloves. Right now I'm ready to take the holder out. To take it out, grab this black piece, and first you want to pull it out straight until you can't do anymore, and then you want to turn counterclockwise until the end, and you pull a little bit more and then turn a little bit. So at this moment you hear like that clicking sound and like open closing the valve. So right now it's very important, you have to stop here and you have to see there's only one button over here. If you can't see it, you see the light, that's a button says pump. Press that pump. And you see another clicking sound. Okay, actually 2 clicking sound. So once you hear the second clicking sound, now you can take it out. And let me show you, that's the JEL holder. This guy is the standard single tilt JEL holder, and your sample will be sitting here. And you see there are 2 O-rings inside here. So it's probably it's easily understood that the part above the O-ring will be kept in high vacuum. So don't touch any part above the O-ring. It's okay to grab here, but don't touch the metal surface above the O-ring with your fingers. Okay, so now I am going to set the sample, and let's move this guy back a little bit. Go to single. So I will grab another camera for this purpose. Okay, I think now everybody can see it. Oh, by the way, if you have some questions, please leave your questions in the chatting area. I will try to stop when I see the questions and answer your questions. And okay, I think I'm mirrored, so I will flip the direction. Okay. So I think right now everybody can see my bench. You see this stand? A piece of metal. So that's the holder stand. So you put the holder on it, and you see this thing. I don't know how to call it, but you see there's a little pin over here, and we will need to detach the holder tip, this part, and put that part on this plastic piece. So to do that, we'll need a screwdriver, we'll need a pair of tweezers. So you want to grab the tip with the tweezers, use the screwdriver. See, there's a hole inside here, so you insert your screwdriver, lift up this piece from the hole, and you should be able to detach it from the holder. And now see, there's a hole here on this tip, and here the hole is where this pin goes. So you can just put it here. So okay, so now we detached the tip, and let's take a look. Let me make it closer. So should be able to see there are two screws, and there is a like a metal piece. I think it's made by copper something on the top, which holds your sample. Your sample will sit here. So first you want to loosen these two screws. You don't have to take them out, so just give it a few turns to lose it. Now with a pair of tweezers, you should be able to move that piece, the metal piece, move that metal piece over, so that you can put your sample here. Okay, and let me load my sample. So today we are just going to show some basic imaging, so I will just use one of my calibration sample. So the sample will sit here. And if you guys are working on the nanoparticles, and you need a carbon, basically carbon film grid, you have, in that case, you have the sample side and the side without sample. So on the JEOL holder, you want to put the sample side facing up. This is only valid for the single tilt, JEOL single tilt holder. And if I'm not gonna talk about the double tilt today, if you need a double tilt, we can cover that in your second training. So once you put your sample here, use your tweezers to move that metal piece back, and now you can tighten those two screws. By the way, if you happen to use our JEOL 2010 and 2100 before, the sample loading and the holder insertion retraction are completely the same. So if you are already a user of on 2100 or the 2010, you should know this very well. So now I loaded my sample. So last step, I'll need to put this tip back to the holder. So I just need to use the screwdriver to lift this piece up, and under this piece there's another pin, the same pin as this one. So you put that pin into the hole on this piece. Okay, so that's the sample loading. See, now it's attached. And usually for sample loading, after I load the sample, I will turn it over, tap it slightly, see if your sample is safely secured. It should be okay. All right. So now we will need to now we will need to insert the holder. To insert the holder, it's basically the opposite. So we moved here. See, this is the holder, and there is a small alignment pin here. I'll move it closer. If you see, if you can see it clearly. So this is the alignment pin over here, and there is a notch on the TEM on the place where you need to insert it. So if don't worry if you cannot see it clearly. You can either go through the video we already made, or we can cover that in the second training, and you won't miss it. It's quite obvious here. It's a notch. So first you want to align this alignment pin with that notch, and just insert it. Don't turn it yet. Just insert it all the way, but don't turn it. So right now it looks like that, and then we want to press that button, the pump button. There's only one button on here, so you won't miss it. So once we press the pump button, the light will go on here. Probably you can see the light. And now the TEM starts to pump. The pumping cycle is about 2 minutes, so you have to wait. And actually, there are 2 more lights here, and the upper one, it says pumping. It's the like some orange color, yellow orange color, whatever you call it. It says pumping. So when you turn on the pump, this light will go on. The other one on the bottom is called holder ready, and it's the green color, and now it's not on yet. When the pumping is ready, that holder ready light will be lit up. So that tells you the holder is ready. It's fully pumped, and we can go to the next step. So right now we just have to wait for the light to come on. We have a very simple version of SOP posted on our farm. So you can also go to the farm and download that latest SOP. But I'll say that SOP is written very briefly. it doesn't contain this much detail. I was just talking. So if you're using that version of the SOP, you will need to take your notes. And actually, I highly recommend you guys take notes. And next time you can just go through your notes and repeat what I do today. So right now the holder ready light is on. Don't worry if you can't see it. When you are here, you won't miss it. It's not right now. It's on. So I will need to grab this black piece and give it a small turn clockwise. And at the same time, after I made that turn, it goes in a little bit, just this much. See, just this much. And this is the first step. And there, I will be doing another big turn clockwise. This turn is quite big. It's like how to say, more than, it's about 90 degrees. And once you turn it, the vacuum will start to pull it in. So hold it and just put it in slowly. And once it's in the position, probably you just heard that clicking sound again. It kind of tells you that I'm ready. The holder is ready. So finally, you can just tap it a little bit. That helps to release any instability. So let's close this cover. So that's the end of the holder insertion. And after we insert the holder, let me move my camera back, because after you insert the holder, you will need to check the pressure again. Make sure you don't mess up the vacuum. So single. Okay, so right now I'm showing the Cosmo PC, and see this live window of the gauge. My needle is here. As long as it's below this black marker. Oopsies, I just saw it jumped a little bit. So when you just inserted your holder, it can do that sometimes, maybe because of the degassing from holder or sample. Let's wait for just a little bit, see if it does that again. Right now it looks like it's stable. Oh, by the way, this gauge is in the unit pascals, which is the SI unit. Actually, I complained a lot of times once when I came to US, because you know, you guys tend to use like Torrs or other different type of units, but in the school I was taught to only this you know, SI unit, and you know the conversion is very complicated. Well, so usually this gauge is set to 10 to -5 scale, and you will need to read the middle line from 0 to 5. No, so right now it's like, if you want to read the pressure, it's like 0.5 times 10 to -5 pascals. And if you want to convert it to torr, you will need to do the conversion yourself. Okay. Right, so let me put my camera back. So I'm doing this now. Yeah. Okay. Oopsies. I need to flip it over. It's mirrored. Okay, give me 1 second when I fix this guy. Okay, so we just checked the pressure is okay. So right now everything is all set. We are ready to turn on the beam. So the beam, the beam valve is on one of the left hand panel. Oh, let me show you where it is. Move it over a little bit. Okay, so see there are 3 panels. 1, 2, 3. This guy is for the corrector tuning. So this guy is the left hand panel, and we have the beam on button over here. And this guy is the right hand panel. So basically we will heavily use these 2 panels for our alignment. And we have set it up in a way that the panels are showing here on with the overlay. So this is the corrector panel. This is my left hand panel. You see my finger pointing, and this is the right hand panel. So the beam on button is right here. You press the beam on, and you sure hear the clicking sound again. Let's go back to Gatan. And I will need to turn off the light, dim it a little bit so that you can see. We will need to check the beam. Okay. Now I will need to move this camera over again. Sorry for that confusion. So now I am viewing this phosphor screen. There are still some weird reflections. So let me turn off the light completely. Okay, so that's our phosphor screen, and right now nothing is showing. Oh, you know what? I forgot one thing. Let me talk about the gun here. Put this guy back. Oopsies. Just set it here. Let's go to TEM-PC. So this TEM has a so-called code fag. It's not like the other 2 TEMs, in which the gun is always on. And this guy, because it has the code fag CFEG, when it's idle, we turn the gun off. So that means you have to manually turn the gun on. The gun control window is here. You can probably see it. See the status. HT is green light, filament green light, A1 green light, mode operation green light. So everything looks normal. So first you have to go to this flashing. See this flashing word, and there's a high flash and low flash. If you are the first user of the day, go ahead and do a high flash. But you make sure, you see here A1, A2, make sure they are all 0. Sometimes you see they are not 0, maybe because the previous user forgot to turn it off. So make sure A1, A2 are all 0, and go to the flash and click the high flash. So just click the high flash and click yes. The software will do that automatically. So it only lasts for 2 seconds, and now it's done. But I have to mention that the high flash is limited to 1 time per day, so only 1 time. If you do that multiple times a day, you're gonna burn the tip, because basically it just it just flows very high current through the tip. So that's saying if you're not sure whether you are the first user or not, you can always do a low flash. This low flash is kind of safe, and I was told that you can do that multiple times a day. Not many times, just 2-3 times a day. There shouldn't be a problem. So if you are not sure, you can instead do a low flash. And also, if you are not the first user, you'll probably see A1 is 0, but A2 is not. At that moment, you can do a low flash, or you can just fire up the gun. Usually it's no problem. So, but again, if you're not sure, you can do a low flash even with the A2 is on. But remember, A1 should be off for all the flashing operations. Yes, the A1 off button is here. I will go back this at the end of the training during the finishing up session. So continue to our gun startup. We did the high flash, and now let's go to the manual CFEG setting button. Click it, and there's a new window popped up. It says CFEG control, and you see A1, A2, and right now they are all set to 0. So what you need to do here is you manually raise the A2. You see this up and down button, and you see this step. Step is a 0.1, no problem, and you just wanna click this up button. You don't want to do it too fast. You can do it just like 1 second a click. So keep doing until you reach 4.7 in here. So you have to memorize that number, 4.7. So do it slowly, 1 second per click. Three 3.2, 3.3, 4, 5, 6, 7, 8, 9, 4, 4.1, 4.2, 4.3, 4.4, 4.5, 4.6, and that's 4.7. So when you get the A2 to 4.7 kilowatt here, you should see the A2 here shows 4.66, and this number, of course, over the time it will change a little bit, but in short period it should be very stable at 4.66. so you can also memorize that number. So now I just close that window, and now we will just need to hit this auto A1. You see this target emission, make sure it's selected to 15 microamp. There are multiple choices, so make sure it's 15, and just click this auto A1, and it says do you want to start up auto A1? You say yes. So now the computer, the software is controlling the A1. It will raise up the A1 until we get 15 microamps of the emission. The emission current is showing here, so right now it's 1. We will expect 15 or something very close to 15 when the auto emission is done. And here, by the way, if you happen to forget the flash, usually what you can see is the auto A1 fails. It will complain like your A1 cannot be greater than A2 or something like that. That usually indicates that you forget to do the flashing. So in that case, you can just close that. You turn off the A1, wait until A1 goes back to 0, and you just go ahead and do low flash with the A2 on here. So you don't have to turn off the A2 to do that, but make sure you do the low flash with the A2 on. If you still want to do a high flash, you have to turn off the A2, which is not recommended. So we're almost there. Now 14 and 15. So now it says auto emission is finished, and you click close. Okay, so now we should be able to, let's see, single. So now, where's my camera? Okay, here. So I'm showing you the right hand panel. Now you should be able to turn on the beam. The beam valve is over here. So click this beam button. You hear a clicking sound, and I'll move to the phosphor screen. Do you see something showing up in the middle like a little triangle? So that's the beam, but it's not yet fully exposed. What you have to do is, you see this trackball, that's the sample, that's to move the sample, and this right hand panel, there's a magnification knob over here. So if you want to move your sample fast, you zoom out basically. So I'll show you the magnification is here. See, right now it's a 20K. That's the lowest mag. So zoom out, and you move this trackball. So there's a course button, you can turn it on. It moves faster while you're looking at here. Okay. Okay, so this is the beam. So right now you have to memorize this beam shape. It's kind of it has a threefold or sixfold symmetry. It's kind of like a hexagon with 3 tails. So if you are if the alignment is not good, the shape can change. So right now you have to memorize this shape. If you get this shape, that indicates that the alignment is not too far off. Okay, so once you found the beam here, then basically you don't have to look at the phosphor screen anymore. And let me put my camera back. Okay. So I think from now on we don't have to move this guy anymore. Okay, that looks good. So right now, for the streaming purpose, I will turn on my light so you can see that clearly. Okay. So once you found the beam, you can go to the digital micrograph window over here, which is on the Gatan PC. See this microscope system, see this big layout, and you can see this pre-GIF button. So you click that pre-GIF, that pre-GIF camera will be inserted automatically. And now you see this live view window. So the live view will start automatically. And the next thing you wanna click this, you see this small screen, because right now the beam is still on the screen. You have to lift up the screen. If you see this layout, you can understand the beam right now is stopped by that screen where the camera is underneath. So if you click this screen, the screen will lit up, and you should be able to see something here. And right now you are seeing my sample, and my sample is just like the gold nanoparticles with the square shape. Okay, so we found the sample. That's good. Next, we are going to do the alignment. So let me go back to the TEM PC. Okay, so because we just inserted the holder, see the Z, that's the Z height we usually say. The Z is close to 0. It's -1 micron. It's not a big problem, so we call it 0. And the first thing we'll need to adjust is the Z height to find the eccentric height. So you see my hand is now on the right hand panel. There is a standard focus button over here. Click that. This button will reset the objective length value. So everything is reset to the standard. And see this Z button over here, Z up, Z down. And while you looking at the image, looking at the image, you change the Z. So let me change the Z. So right now I'm going up. See, the image is going away from us. It's like zooming out. So that's not the direction we want. So if we do Z down, it's going toward us. So that's the direction we want. We want to zoom in and in and in and in. So when you get very close to the image, the sample, your sample will start to show some like weird thing, like something here. But if you keep going, so right now it's looking very funny, very weird. That's it. This is actually very important. It's the ronchigram. That's the thing we will need to use during our alignment. But I want to tell you one thing is, because I just moved the Z down. So if you keep moving it down, so everything is flipped, the image starts to going away from us. See that point? So right now I'm moving up, it starts to go toward us again and go to that point, and if we continue to go, it will go away from us. So this point is a crossover point, and that's the point we want to find now. And on the SOP we say it's the eccentric height. This height is very important. On the TEMs, most of the TEMs we will need to find this height first. At this height, the TEM is supposed to give you best resolution. So when you press this standard focus, everything should be reset to the standard value, which were calibrated just at the eccentric height. So standard focus, Z height, make sure you find this eccentric height. And now we will need to change the mag. See the mag over here right now, because we just zoom out when we try to move the sample. Right now we are ready for the alignment, so we will need to zoom in. We'll zoom in to at least 600K, but I usually use 2 milling. I found this mag. Of course you can use 3 milling, 4 milling. Anything about 600K should be good. Just my personal preference, I just like this mag. So when you actually change the mag, you see this pattern. It changed just a little bit. That's because in the low mag and high mag, there are different scanning circuit. So you will see the beam changes a little bit. And right now I am moving my sample, and you see that pattern will move. Okay, so now I'm going back to the right hand panel. You see the objective focus knob. There are 2 knobs. The small one is the fine, and the big one is the coarse. And you have a coarse button over here as well. So if you change the objective focus knob, it works in the same way as the Z height. See, if I change, now I'm turning to the counterclockwise, so my sample is moving away from me. So I'm going the opposite. Now it's going toward us until we reach to somewhere here, and that's a crossover point. If I keep going, the image will zoom out again. Okay, so it works kind of as the same way as the Z height, but they are actually different. Z height is moving the sample physically, and the objective focus, of course, is changing the focal point of the objective lens. Okay, for the alignment, we will need to move the sample and find an amorphous area. So let's move it. For that purpose, we can zoom out so that we have a bigger field of view. So this sample is deposited very dense. So maybe we can go to somewhere here. See, here I have a little bit less particle showing up. And if I zoom in, when you are very close, you start to see the lattice, but that's not the thing we are interested in. So we keep zooming. Okay, so if we keep zooming, then it's if we keep changing the objective focus, there's a crossover. Okay, so we will need to find this crossover point and stay there. So usually when everything's aligned, you should be able to see an hexagon or something with a 6-fold symmetry, but right now it's just something weird here, and now that's the reason why we want to start alignment. We want to make it we want to adjust it so that we can see the nice hexagon. So this is the ronchigram. I'm not going to go too deep on this. If you are interested, you can, I think in our TEM seminar we have something listed, and also you can find out some reference talking about the ronchigram. I'm sure there are a lot. So the ronchigram is the important indicator for the alignment. So for the alignment, what we have to do, we will only have to do two things. One thing is the beam tilt, which is here, the left-hand panel. Here there's a button that says bright tilt. Click that, and now there's a deflector X on the left panel, deflector Y on the right hand panel. So if we click the bright tilt, so now these two knobs are assigned to the beam tilt. So we will need to fix the beam tilt. Another thing we'll need to do is the astigmatism. On the aberration corrected TEM is usually called A1, but this is just the JEOL's nominations. There are some TEMs, depending on what corrector they are using, they may have different names for them. But here I prefer to use JEOL's nominations. We called the astigmatism A1, and the beam tilt is called B2. The focus is called C1. The A1 is controlled on this corrector panel. So see this corrector panel, there are many buttons. Do not touch the buttons other than the things I tell you in this training. So here first you have stem TEM button. So that's a kind of just a switch. Because we are in the stem mode, we will need to adjust the stem corrector. So we press the stem. So the stem is lit up. And now we go to just the right corner. there are a bunch of buttons. Make sure you have the first button, C/F, selected. This one's lit up, and when it's on the C/F, this XY are the astigmatism, the A1. And now I will tell you how to do that. You know, to correct it, first you need to make sure, you need to find out it's good or not good. So let's go to a amorphous region here. So when I change my focus, so again we will need to find the Ronchigram, which is the crossover point. And now when I get closer, you see a lot of lines. And if I change my focus, see the line disappeared and reappear with a 90-degree rotation. So these lines are clear indicator of the astigmatism A1. So again, remember the indicator of the A1, you'll see the lines, and when you change the focus, the line will rotate 90 degrees. So you will need to see both the lines and the rotation of 90. So that tells you you have A1. Okay, so to correct A1, we'll have to go to the corrector panel. See the stem, C/F. Now the XY knob here are the A1. So let's there's a course. So see, when I change, the pattern changes. So we want to go to the direction that we have the lines like corrected. So right now we don't see too many lines again. Let's let's change the focus. See the lines. So let's play with these two knobs again. So I'm going this way. You see the lines are you know, getting more and more. So you wanna, that tells you you're going the wrong direction. So right now, see the lines are, you know, getting wider. But if I keep going, you see the lines are shrinking together. So that tells you you just passed that good position. So go back to see here. Okay, this is probably the best you can do now. Then let's try the Y. See, now this is like your lines are like shrinking. So go to the opposite. So right now the lines are like really spread it out. But if you keep going, you start to see the lines again. So come back and stop here. So probably this the best you can do now. And actually at the same time, you now start to see this kind of flower shape or some kind of like six-fold symmetry. That's great. So next we will need to check, we'll need to fix the beam tilt. To fix the beam tilt, it's all about the symmetry. Oopsies. See, my sample just jumped. So let's move it a little bit. Okay. It's better to do this on the amorphous region where you don't have the like your sample, like the particles there. Otherwise, the Ronchigram will look very complicated. So right now, actually the beam tilt is very close. So to fix the beam tilt, to tell whether a beam tilt is good or not, you will need to look at this Ronchigram and find the symmetry. So right now, you kind of see like there are more lines to the left side, but you know, if you compare up and down, they're kind of symmetric, but if you compare left and right, they're not. More lines on the left and less lines on the right. That kind of tells you your beam is like probably tilted horizontally. So you turn on the bright tilt and change the deflector X. So right now I'm changing X. You see, right now it's more non-symmetric. See, have a lot of lines here, but no lines here. That tells you you go to the wrong direction. So going back. So if you stop here and tell it by your eyes, the pattern now it looks a little bit like more symmetric horizontally, and I'll see the up and down looks just a little bit off. So do the Y knob. See, if you do Y and it tilts up and down, see. So make it symmetric. Change focus a little bit to see it clearly. Okay, so now you start to see this six-fold symmetry. See? So actually, today the alignment is not bad. I didn't have to do too much to bring it to this stage, but sometimes you see it's not as good as today, so you have to repeat the A1 and the B2, which B2 is the bright tilt, A1 is here C/F XY, and I already showed you what is bad. For example, I can probably show you again. If I mess up the B2, see now it's not symmetric, and now it's good, now it's not, right? I'm messing up the Y direction, now it's not symmetric. Going back, now it's kind of symmetric, and now it's not. And by the way, we just burned a hole on the carbon film, because when our beam is kind of well aligned, it's very focused, it can burn a hole very easily. So in that case, you have to move a little bit. Okay, and let me play with the A1 again. So I'm messing up A1. Now you see the lines showing up. Going back, now you see the lines again. So going back, playing with the other one. So that's the line, and now that's kind of symmetric. Go again. So that's another line in another set of lines in different directions. So you wanna kind of go to this middle where you can see clear lines. Okay. So that's the manual alignment. it's not ready yet, but manually, if especially for the beginners, if you can get this far, it's good enough to go to the next step. So the next step, we will need to go to, let me see, the corrector PC. Okay, so this page, the corrector PC, and see corrector, CS corrector. This there is one for STEM and one for TEM. So make sure you select the STEM, HT settings, 300 kV, and the important things are here. So these are the alignment files. So the software allows you to save your alignment at that moment. It doesn't mean that you can always go back to that perfect status, but if you load a known good alignment file, that will give you a good start. So if you click this open this folder icon, usually you will go to, it will be prompted to this location. You'll find my folder and a bunch of my alignment. Every time when I use the TEM, I will do a good alignment and save the file here. So just choose the latest one, but you know, you want to do that before your manual alignment, because once you load the alignment file, it will override all the manual changes you did just now. So I won't do it now, but sometimes if you found that it's too hard to get a good condition, you will want to go to here and load some known good alignment. The same thing as the TEM CS corrector. One thing I have to mention is that in the STEM mode, both your TEM and the STEM correctors are working. So you will need a good valid alignment for the TEM corrector as well. So for the TEM corrector, the same thing, you can find the latest file in my folder. Okay, so let's double check our sample. You see the film is burnt again. Let's move to another position. Let's see. So again, we want somewhere that has less particles, because we really, what we want is a thin amorphous area. So how about here? So now I'm doing this by changing the objective lens focus. Okay, so come to somewhere here, and let's go back to the corrector PC here, and so make sure it's a 300 kV, everything is set, and let's change the defocus to, let's start with 150, and let's just click this single. Okay, so when you see this message, let's click OK and go back to the GTEM PC. Go back to the GTEM PC and right, and click this. There's a small icon over here, which is called Cosmo Image Provider. Right click this Cosmo Image Provider and click Search DM Plugin. So just one single click. And once you do that, you should be able to fix that problem. If still you cannot fix, just come to my office. Okay, let's change our sample position, go back to the corrector PC, and let's click single again. It should capture. Okay. Alright, so now it captured an under focus image and over focus image. And you see this green or yellow circle. If you select this yellow circle, and you use the wheel on your mouse, you should be able to change the size. And if you drag it, you can change the position. So you have to see this kind of six-fold symmetry over here. So you want to first place this circle to the center of this six-fold pattern, and you want to change the size so that the outer edge is just like reaching these this area with the lines, like these 6 corners, something like that. Okay, so after you have changed this pattern, you can click this aberration button again. So this way the software just re-evaluates the aberrations from these 2 images. All right, let's see. I see that. Let me change one thing. Okay, so in here, in this window, you can see the aberration coefficients the software calculated from these 2 images. So we just talked the C1 is the focus, A1 is the stigmatism, B2 is the beam tilt, and we have A2, which is called 3-fold astigmatism, and we have C3. C3 is the spherical aberration. So we usually call this TEM CS corrected TEM. That CS is the C3. And we also have S3, A3, and all other stuff. So manually, we should only be able to change C1, A1, B2. Of course, if you have more experiences, you can also manually change A2, C3, S3, A3, those kind of stuff. But they are not recommended. Just use software to control those. So for the manual alignment, just like what I did, I just adjust the C1, A1, B2. A1 is again the astigmatism we did in here, and B2 is the beam tilt we did here, and we were able to get this nice 6-fold symmetry. Then we came to this software. So now we did the calculation, and software thinks the B2 is 147 nanometers, A2 is 42. So B2, A2, usually what can be considered as good is something like around 50 or below. So right now B2 apparently is big, A2 is big, and also C1, A1, it can be as close as 0. Like anything like below 5 nanometers should be good. But since we got this calculation, we can come to this button. This button says run, and you have C1, A1, B2, A2 selected. So if you click run, it looks like nothing happened, but actually in the background, the software just corrected whatever calculated here. Of course, the calculation can have error, so that we will need to run the single again. Oh, see, our sample is moved. We'll need to move the sample a little bit. Go to this amorphous region. Come to here, and let's go back to the corrector and click single, and let the software to evaluate again. Okay, so right now it looks like everything is very low with very small value. And see this face map, there are some small words indicated here. The first line is pi over 4, the second line pi over 2, and the third line is pi. So here we only read the pi over 4 value, and now it says 20. We want this value as big as possible. So 20, we are kind of satisfied. So let's decrease defocus to like 100 and do the single again. Okay, so now it got some value, and you can click run and single, and run. So just basically repeat this procedure. Okay, so now I see my film is kind of broken. So we'll need to change to another position. So click the single, and run. So again, we're targeting this value to the pi over 4 value to increase. So 19. So see, the B2 is still a bit high. We can run single. Okay, so now it looks pretty low. The lower value, lower order values, A1, B2, A2. Now we see C3 is kind of big. It's a minus 2.5. So basically we want C3, S3, A3 to be around 1 micron. So right now C3, S3 and A3 are good. C3 is minus 2.5. So we can click this C3 button here. Suppose it will correct the C3. So let's run it again. So once you correct any of these higher orders, C3, S3, A3, it will mess up your lower order, like these A1, B2, A2 stuff. So the basic procedure is that you do this single, and you click run, which corrects your lower order aberrations. Then when the lower orders are all in a good range, you can start to correct the higher order aberrations. So my film is broken. I will change to another position. Run single. And let's run. single. So you basically just repeat this until you get a good value. If you get more experience, actually the manual alignment is faster than this for the lower order aberrations. So if you get more experienced, you can do the manual alignment for the lower orders and correct those lower orders and come back here to correct the higher order and do the manual again. But probably for the beginners, this software automatic correction is kind of more straightforward. Okay, it's taking too much time, so I will try to do some manual correction. So now I see the lines, that's the A1. So we will change the A1 up. Now let's go back to the corrector, run a single. Let's run again. Okay, so now I'm starting to get pi over for about 21 millirad. So now we can decrease the defocus to 50 and run that single again. Oh, my film is broken. So let's move to another position. So let's run the single. So if we are using smaller defocus, you see that pattern is kind of small. We can resize the this calculating area and make sure it's still centered. Click aberration button to reevaluate, and let's just run single. Let's run, and I see my film is broken. Let's find somewhere else. Maybe here is good. See, the alignment actually takes a lot of time, so if you really want to push your resolution and want to get good high resolution images, you really want to work hard on the alignment. Film's broken again. So this value I'm getting 18. This is bad because the A1 getting better. Okay, let's change to another position. See, if you're working on the carbon film, you need to constantly change your position. Once your film is broken, this calculation is not accurate anymore. Kind of annoying that the film keeps broken. I'll do some manual alignment here. So let's see. Okay, so now the pi over 4 says 22 millirad. The 24 is 22 is our target because we are going to use the number 3 condenser lens aperture, which is only 22 millirad. So we will need just any value that is bigger than 22. So today, to save time, we will stop here. We'll stop here. We'll call it done, and let's come to the left-hand panel, select CL1 and press the number 3 dot. Okay, so now you see the aperture goes in, and right now if you wobble your beam with the objective focus, you kind of can find the center where it shrinks and expands. Like I'll use my mouse cursor. So if I change the objective lens focus, you see the image is wobbling through this center where my mouse is indicated somewhere there. So I can show you again. So somewhere there. So next we will need to move our aperture right on that center. To move aperture, we'll go to the left-hand panel, see the aperture control. There are 4 arrow keys. There's a coarse fine button. So we'll need to move the aperture using these keys, the arrow keys. So somewhere there. Okay. So right now, if I change the objective focus again, it feels like the image is changing concentrically to my aperture. I will just a little bit more. Okay, so now it's kind of concentric, so that's good. We call it done. And the one thing, once you have your aperture in, you will start to see just a little bit A1, you know, the lines changing direction. That's because when you put the aperture in, the aperture can actually affect the beam a little bit, and then when aperture blocks out or most part of the beam, you can also see that residual aberrations more clearly. So if you want, you can play with the A1 a little bit to get rid of that just a little bit residual aberrations. So right now you see the things inside the aperture is really featureless. This is what we want. We want that the things inside as featureless as possible, and we call it flat. Some people prefer to say, oh, there's a big flat area. So if you hear that, that means you cannot see anything. It's featureless inside. Okay, so there's one more thing we have to do. Let's minimize this. Right. So in the ASID control, which is on the TM PC, you see this image select over here. Now it's set none. You have to select this STEIDF, which is the JEOL HDF detector. So select that, and you see this in. It's automatically checked. Now you probably just heard that clicking sound. The HDF detector is automatically inserted. And let's go back to the HDF. The GATAN. Actually, you can see that HDF detector. If you can't, go to display, and I will change the gamma a little bit. So now you see the edge. This is your HDF, the edge of your HDF detector, and you will need to align this beam or this flat area of the ronchigram to the center of the HDF detector. To do this, you will have to come to the left-hand panel again. Now we will use the PLA button over here. So you don't want to touch the aperture keys again. You use the PLA and use deflector XY. So see, now I'm able to move that aperture, no, not aperture, the beam. So let's move it to the center, and that's it. So that's the end of the alignment. Okay, so finally we come to the end of the alignment, and we are ready to get some images. So let's click this pre-GIF. Click this pre-GIF again. So now the pre-GIF is stopped, and right-click that pre-GIF and say retract. So now the pre-GIF is out. Then to get images, we go to this so-called technique manager. There are TEM, STEM, analytical. So STEM, and we click STEM imaging. See the scan, and there's a view button. If I click view, so now I'm getting a scanning image, and here this guy is called JEOL detector image. The JEOL detector is the HDF detector we just selected. Let me show you here. So it actually has a bright field detector too, but we usually don't use this bright field. So we always use this hardF. When we select this, that signal is gonna be thrown over here. So now we get the hardF image from the JEOL detector. And sometimes we will want to use want to get the bright field images as well. So come to here. There are 3 buttons: hardF, ADF, and BF. So ignore this hardF. This hardF is not the JEOL hardF. This is only used when we try to get use. So ignore this and see this BF and ADF. They are on the same rack. So that means you can only select one between the two. So if you click this BF, click that, okay. So right now we're getting the bright field. And if you click this ADF, it's a kind of smaller annular detector. Depending on the configurations, we can get like low or medium angle annular dark field, or annular bright field, or something like that. But this is not used very often. So sometimes you just want to get bright field, so just click the bright field. So right now we get the JEOL hardF and the bright field at the same time. So the rest of the story is easy. You can move your sample and find the region of interest and zoom in. So like here, I get one particle or a few gold nanoparticles showing, and you can already see that the lattice fringes are shown in the bright field. Say we are interested in getting a good image here, we can zoom in and focus. So now see, we get a very good lattice image. Zoom out a little bit. Say we're satisfied with this image, we can come to this scan and click this capture. So now the Gatan digital micrograph is capturing the images, actually 2 images at the same time. Here I also want to point out that I just use this focus knob to change the focus to get a sharp image. But here, actually the concept is somewhat similar to the SEM. Sometimes only the objective focus is not enough to get a good image. Also, you will have to tweak the astigmatism A1, which is here. So I will show you. So right now it looks good. If you move it over, see this area, it looks pretty sharp. But if I change my A1 to do this, one click. So you see now it's blurry. If I change my focus, I cannot get the image as sharp as before. So in this case, you wanna also play with your A1. The same thing, I just changed the X and let me change Y. So now it's blurry and you cannot get the sharp image again. So now it looks good. there's still a little bit, I can see it. So the astigmatism on the image will look like your image has a distortion. So let me show that. When I zoom out, I'll do 1 click, 2 click, 3 click, 4 click. So now you can see, oopsies, my sample is kind of dirty. So now the image is like stretched perpendicularly, and if I change my focus, now it's stretched horizontally. So that's basically the same as the astigmatism, how the astigmatism looks like on the SEM. So change it back. So now I can get a sharp image. So zooming and focus. And if you are satisfied, just click this capture, so you can get a scanning image. And all the images you captured will be saved in a different tab. So right now we are in the view tab. If you go to, so let's wait for it to finish. Okay, so let's go back to the stem. So we just captured 1, 2, 3, 4 images. They will be all showing here. And if you want to save, you can either right click, save, or save as. Okay, so you get this pop-up window, say save image as. I recommend to save the images on the local hard drive first. So you can save it to the X drive. It says RAID. So you can create your folder here. For example, let's create a training, and you can save your images here. The same thing as this guy. Save here. So this is how to save the images individually. Instead, you can right click on the tab. This says stem 1. Right click tab and say save workspace as. So I'm still in the training, and you give it a name and save. And let's take a look. RAID training. So these are the images we just saved separately, but see, there's a folder because we just saved, we did the save workspace as. It will automatically create a folder and save all the images inside this tab to here. So now we got 2 images saved together. So when you are done with your session, you can copy this folder, say copy, and go to any of the emo server we have. We have emo data and emo data 2. I personally save my data in the emo data 2 because it has more space. You can go to JEOL 3100 and users. So you create your folder here, or you can just save the folder you copied there. So training, So in this way, you can get access to your data from our server. Of course, you can use USB. In that case, please only use the USB stick we have on the front desk. Okay, so now what time? It's already 12:50. I will say this is pretty much everything I have for today's training. Do you have any questions regarding the training? Anything? If you have questions in mind, please type in the chat area. Right now I am looking at the chat area and I didn't see anything. And I see there are only 5 people watching. So again, after this training, only the people who have watched during this training will be granted the daytime access, because apparently there were more contacting me before, but since they didn't show up, I won't give the access to those guys. And looks like we don't have questions posted in the chatting area. Now I assume that everybody is okay right now. Of course, you can always come back to watch this video, and you can always email me and or come to my office, find me if you have questions. So because of the time, let's finish this session. So say now you're done with your experiment, you want to finish up. Okay, so to finish up, let's turn off the beam valve first. So go to the left hand panel, click that. Okay, so you heard the clicking sound, and then let's click this open to remove the aperture. So click this open. Okay, now the aperture is open, and then let's go to the TEM-PC. So first, let's remove the hard disk detector. So we just uncheck this in, and we can hear the clicking sound. So right now the in is unchecked. That means the aperture, the detector, the hard disk detector is out. Okay, so next we will need to reset the stage. We'll need to neutralize the stage. You see this stage neutral button? You just double click that. See this window popped up. So now see position neutralize OK and click OK. Alright, so next we will need to, we are ready to remove the holder. So let's go to the GoPro. Okay, am I still alive? Okay, so this is the holder. Right now we are ready to remove the holder. So again, before you remove the holder, make sure your beam is closed, beam valve is closed, which we already did, and make sure the stage is neutralized, which we already did. So now we are ready to take it out. To take it out, we can just grab this black piece and pull it straight and turn counterclockwise and pull a little bit more and turn and stop. and let's press that pump button. Okay, we hear that clicking sound. Now we can take the holder out. Okay, and we can now set the holder on the sample prep bench, and you can remove your sample or exchange your sample just as what I showed you just now. I will not go through that, but I require, after you are done, let's put that single tilt holder back here. So again, I will not do this today because of the time, but basically you remove your sample and you insert the holder here with the empty holder here. Okay, so pretend we just inserted the holder. There's one more thing we need to do. So let's go to the TEM-PC, see this CFEG client control, and see this A1 off button. So after we are done, we'll need to turn off the A1. So just click this button and click yes. See, this A1 value is decreasing. The software will turn off the A1 automatically. And if you are the last user of the day, after turning off the A1, you will also go to manual CFEG control and turn off the A2. So you just click this down. So let's turn it off. But let's wait for the A1 first. You do that only if you are the last user. So you can check the schedule. If there's another user coming after you, you can leave the A2 on, but make sure you turn off the A1. So pretend we are the last user of the day. We can also turn off the A2. So just click this down button. When you want to turn the A2 off, you can do that quickly. It doesn't matter. So now it says 0, and now here this A1 is 0. And go to here. So only if you are the last user, there is one more thing you have to do. Let me move my camera a little bit. See that nitrogen tank, and you see this thing. So this thing, again, if you are the first user of the day, you will see this thing is inside that tank. And if you are not, of course, the tank should be filled with nitrogen, and you need to top it up. But if you are the last user of the day, if you are not, then you can just now leave, and don't forget to log off from the farm. But if you are the last user of the day, you need to put this guy back to that ACD tank. So remove the cover. Oopsies. Oopsies. There's a fire alarm. Okay, so probably I have to go out, and I will close this session. But we will cover this in the one-to-one training. But basically, you just put this in, and you turn on the ACD heat. So I think I will need to vacate because there's a fire alarm. Okay, I'll stop the streaming, and thank you everybody. Again, if you have a question, send me an email. Okay, thank you very much to signing up.